Hello and welcome to more enterprise Unity development with UniRX and MVP Toolkit. Hi, my name is András Ververt and you can see my contact information on the screen right now. So what does it mean to have an enterprise Unity application? Well, it certainly doesn't mean this kind of enterprise, but what am I talking about here? I'm talking about this. I'm talking about when enterprises use HoloLens, virtual reality devices, Magic Leap, whatever, to give their first line workers access to hands-free interaction with computer technology. This is a great example of how somebody just learning to put together an engine is directed by this application that tells them where to put the regulator and how to put it in position. Another example is a project I'm working on currently at UniRX. The photo that you see here uses a Magic Leap device, but our application is currently running on a HoloLens 2. And what it does is help airplane maintenance engineers to streamline their work with these projected augmented reality grids. In the end, ultimately increase aviation safety, which is a good news for every one of us who is ever going to get on a plane if this current pandemic is over. So how does Unity come into the picture? Well, these fancy new devices, they literally just jumped at the enterprises and said, well, here we are. You could do some fancy stuff with us and you could actually positively affect the business. So the companies, these big companies, they started to think about how they can develop prototypes and pilots and actual projects using these devices. And obviously, they went to, for example, Microsoft and asked, well, how can you create an application for HoloLens? And the answer was, okay, you should use Unity. So enterprises started hiring Unity developers. So there were a lot of game developers going into the enterprise and bringing their existing game development way of thinking about architecture and projects and everything else with them. So because of all of this and the focus on performance and the best possible graphics and whatnot, Unity has a very game-oriented architecture, which is somewhat different than what we're used to in the business application or line of business application development world. It also is not aimed for long-term support. As we said earlier, most of the games have a very short life cycle, and even the Unity engine itself, the long-term support versions of Unity are only supported for 2 years. So that means that if you have a Unity project that goes on for more than 2 years, you will have to upgrade every 2 years to a new Unity version, or even every 1 year. And that's not really how enterprises work. Unity also has a very game-oriented development workflow. There is still a lot of difference in how you approach an application that has to live for 5, 10 years, and how you approach a game that is a few months of development and then it goes at the store, maybe a few patches, and you're done. So what does an enterprise, a long-term development need? Well, first of all, it needs readable code. That's very important because developers may come and go, and you do want people to be able to read the code even after you've left. Or, I don't know if you have seen your own code after half a year. It's like somebody totally stranger wrote it. So readable code is more important than performance. Same goes for testability. As the application grows, you really want to make sure that you haven't screwed up anything, and that may actually incite you to do test-driven development. Yes. And one of the most important part is to separate the logic and the presentation. And that's a tool for you to do all of these things. We're going to talk about that. You have to do this separation in the architecture as well as during the workflow itself. As an architect, my task is to create an architecture that makes people fall into the pit of success. Falling into a pit of success basically means that a well designed system is going to make it easy for the developers to do the right things and makes it very annoying to do the wrong things. All of the above are very useful for any large project. For the small projects that most Unity developers are familiar with, so projects that last from a few weeks to a few months, you don't need a lot of these. Some very, very good developers that I was lucky enough to work with have developed these habits, or at least parts of these habits by themselves, but you're not forced in small projects to work and think this way. But if you're creating a larger project, then yes, you are. Companies hire Unity developers who may not have experience in large projects to create small prototypes. The smaller prototypes, they work well. You don't run into a lot of the maintenance problems that I was talking about if you're only developing something like this. But then the prototypes are successful and you have to create something bigger. And obviously, you have to have a different mindset to create this or to create this. It's different. So let's talk a bit about how I used to develop applications, enterprise applications with MVVM, WPF, Silverlight, Windows Universal Applications, and so on. The first thing that I usually did is that I was coding the view models, which is basically the data and the logic of the application. But the view models don't know anything about how the application is going to look like. It doesn't know if a list is going to be presented as a dropdown or scrollable list box, whatever. It doesn't care about that. So I was calling the view models and I validated the view models with unit tests. And I even practiced test-driven development. Now, once that was done, either me or a colleague of mine was creating XAML. And this way we could build up the entire application and, things just worked on first try. Once they created the XAML, or if it was me, once I created the XAML, I just pressed F5, and because the logic was already tested, the whole thing just works the first try, yeah?
Pow, wham, first try.
Yeah, like that. So first try 90% of the time. So when I started working with Unity instead of XAML and MVVM, I found that I was really missing this way of working. And I started looking for a way to have a similar workflow and a similar method of working when creating Unity applications instead of games. And believe it or not, it all just comes down to two things. If you can do these two things, you can pretty much duplicate the same results, including getting most of the application right 90% of the time on first run. So what are these two things? Well, the two keys to achieving this is separation of logic and presentation and a testable logic. So a logic layer that you can just test separately from the rest of the application anytime at the press of a button. Automatic tests are cool. So let's talk about the first thing first. Separation of logic and presentation. To understand what this means, let's go back to the 80s. This was my very first meeting with video games and, to be honest, computers in general. This is an LCD handheld game. And the way it works is that, let me just show it to you. Here is the game itself, and listen to the sounds as well. So airplanes come at the top, they drop bombs. I'm controlling this little tank here. Now the goal is to go to cross this bridge and enter this safe area on the right. Now, what the hell does this have to do with anything regarding the HoloLens? Well, it turns out that in order to create software for this game, what you had to do is create ROMs. ROMs are read-only memories. This is this is how small it is. The entire thing I showed you was smaller than a fingernail. And this is zoomed in into that. You can see the ones and zeros that basically make up the entire ROM of this device. Now, this thing, it took weeks to be printed. You would carefully insert it into your circuits and hoped it worked. So today software is really, really cheap to change, but back then software wasn't cheap to change. So these game manufacturers, what they did was they reused the same software with different designs. They separated the design from the presentation. So let me show you this other game. This game uses the exact same software or ROM as the previous one, but it has a different design. So the game itself is about a little man on a boat, and instead of crossing a bridge, I have to cross this area between my island and the ship. And instead of rockets and bombs, I have to avoid sharks and coconuts. So this is true separation of design and presentation. The title of this talk was More Enterprise Unity Development with UniRX and MVPToolkit. We have covered what enterprise means, so let's talk about UniRX next. So what is UniRX? As you can see here, UniRX is a re-implementation of the .NET reactive extensions, taking Unity into consideration. And it also has a couple of nice features that make your Unity life easier. Let me do a very quick introduction if you're not familiar with the reactive framework. This won't teach you everything reactive has to offer, just enough so that you can understand what I'm going to talk about next. You can simply add UniRX to your project by going to the asset store, going to UniRX, here it is, clicking on it, and importing it into your project. Once this is done, you can see that it is here in the plugins directory. So I want to set up the Unity solution, the Unity project, so that it supports edit mode testing. This is going to come in handy later. So I'm going to click here the create edit mode test assembly folder, and I'm going to say this is this test assembly, and I'm going to add UniRX to this because we are going to need it. So UniRX is added to that. In addition to this, I'm going to need a global assembly definition for the actual application that we're going to use. So I'm going to apply that and create a new assembly definition, and I'm going to call it Enterprise Demo. And here, again, I'm going to add to this one the UniRX assembly. So now our project is set up for UniRX. And let me now show you the basics of UniRX. I'm going to create a new test script here, UniRX Playground. There it is. And I open it in Rider, which is my editor of choice. I'll get rid of all of these. So first I'm going to create a simple test that will just show you the basics of a reactive property. So here is how you declare a reactive property, new reactive property. And because we have added all the assembly definitions, UniRX already shows up here. And this is going to be a reactive property of type string. You can think of reactive properties as properties that are observable. And let me show you what that means. I'm going to say that this property, whenever it changes, it should execute this action. So we're going to have on X, which is going to be a string, and we're going to execute the action where we're going to just simple console write line um, the X, new X, new X value, X like this. You have to change its value because the prop is this whole entire reactive property. But it has something that's called a value. And we can say prop.value equals AAA, and then prop.value equals BBB, and then prop.value equals CCC, for example, and so on. Let me run this little test that we have here. This is not really a test. It doesn't test anything. It doesn't assert anything, but still, it's a small piece of code that it's easiest to run like this. So I'm going to run this. And as you can see here, we have the new X value empty string, which is the default value here. And then we have A, B, and C. And if I just change default value to, I don't know, XXX and run it again, then you can see that the values have arrived like this. So whenever this value changes, this little action right here executes. So pretty straightforward so far, right? What I can do now is I can filter this value. So I can just say that let's just only write out those where the length of the string is at least 3. So obviously this is not going to change anything now because all of these are at least 3 characters long. But if I just remove one letter from the B and run it, you can see that the subscription has been filtered. It only takes into account those strings that are longer than 3. And I can also do things like skip 2. So it's going to take those that have a length of 3 and skip the first 2. So what we're going to say is this is going to be skipped, this is going to be skipped. This is not even going to get to the skip because it is already failing at this where point, and then it should only print out the C. Let's see that. Yep, it did exactly what we were thinking it would do. Now, another thing that it can do is it can filter the same values. If you set the property to the same value multiple times, it's not going to have an effect. Let's see. This hasn't done anything to the skip because the second set to AAA hasn't even fired any events, and the observable has not gone through this whole chain. So as you can see, these properties, these reactive properties, they work very similarly to what you may be used to in the MVVM world as the iNotify property changed pattern. But this is much more powerful because you can just simply filter the events as you like, create different subscriptions, and react to those property changes as you wish. And there's a lot more thing to reactive properties and observables in general in UniRX. But this is going to be a good starting point for us for the rest of this session. Let me show you next how you can take advantage of reactive properties in Unity. For this, I'm going to create, in the scripts, I'm going to create a folder called models. And in the models folder, I'm going to create a new class, which is going to be called cube model. So this is going to be the first piece of the MVP, the model view presenter architecture that we're going to build. And this cube model, this is only going to have for now a simple property, public reactive property. This is just going to be a Boolean property, bool marked for removal. And we can even instantiate it right here. Okay, so this is just a property, nothing else. And we're going to create a test scene. This is how I usually work with bigger projects. So I'm going to create a test scene. This is going to be cube presenter test scene. And all this scene is going to do is have the environment to test whatever the cube presenter is going to do. So I'm going to add here an empty cube like that. It's a bit too big though. Okay, so we have a nice cube here. It's fine. And I'm going to add a script. And this script is going to live in the scripts slash presenters folder. And I'm going to go here and I'm going to create a script now. It's going to be called cube presenter. And I'm going to add this script to the cube so that it's attached. And now let's edit this script. So this cube presenter, it is going to have a reference to a cube model. But there are different strategies of whether you want to create the model first or the presenter first. And even in the same project, there can be places when one makes sense or the other makes sense. For now, the model is going to be part of the presenter. So the presenter has something, I'm going to make it private cube model. And this is going to be our cube model. And I'm going to initialize it in the start, for example. And what I want to do is in the presenter, I want to change the appearance of this cube depending on the value of the marked for removal property. So the way to do that is very simple. I'm going to say that our material, and this is going to be created obviously a bit later, get component match renderer and that material. And I can just create this field right here. Okay. So this is going to be our material. And now I'm going to subscribe to the model's marked for removal property. So I'm going to say model, sorry, cube model, and I should have had it lowercase q. Cube model dot marked for removal dot subscribe. And then I'm going to say this is going to give us a Boolean. So wherever the marked for removal property changes, it's going to give us a Boolean. And this little action that I'm writing right here is going to run. But subscribe here should be with the UniRX and not the default subscribe. So this is very important to use the UniRX one here. So what we're going to do is material dot color, and that's going to depend on whether the Boolean is set to true or false. So when it's true, I'm going to say color dot blue. When it's false, I'm going to say color dot white. Now, obviously, this is just a very, very simple example. But this is all it takes for us in the presenter side to react when the cube model's marked for removal property changes. This part here is only going to run when the property has actually changed. So we don't have to check its value in the update every single time it changes. We don't have to write separate events, nothing like that. This is as simple as it gets. So now that we have done this, if you go back to Unity, you can see that here's the script, but there's no way for us to change the value, the actual value of this model. So to make that happen, we have to do a couple of things. First, we have to serialize this field. This makes it available for the Unity editor, but still there's nothing here. And the reason there's nothing here is because the cube model itself needs to be marked as serializable. So now we actually have the cube model here, but the property doesn't show up yet. And the reason the property doesn't show up is because reactive property doesn't have a dedicated editor. But some of the more common types actually do. So one of them is bool reactive property, and you have string reactive property, int reactive property, a couple others. So if I change this to bool reactive property, and I go back to Unity, then after it compiles, you can open the cube model and you can change this. And now all I have to do is actually launch the application, and I'm going to switch this property, and you can see that the cube changes its color depending on what the value of this property is. Let's get to the last part of the presentation and talk about MVP Toolkit. MVP Toolkit for Unity is an implementation of the Model View Presenter pattern for Unity. I created it to help you implement this pattern with a couple of simple classes and use cases. I recommend that you use the experimental branch because it is much more advanced than the master branch, but it may be merged into the master branch by the time you're viewing this presentation. MVP Toolkit includes a couple of scripts that you can use to include in your own application, and it allows you to follow the MVP pattern properly. It also includes a full demonstration application that shows you the architecture that encompasses the learnings that I have gathered in the last couple of years creating enterprise Unity applications. This demo app is small, but it illustrates a lot of the patterns and architectural approaches that I'm using in much larger projects. So let me just show you how it works. I press play and a couple of cubes start falling. There is this info panel which shows you that there's always 4 active cubes, and after a few bounces, the cubes become inactive, blue, and then disappear after a few seconds. Let's explore the code behind this. We're starting from the cube model, which may be familiar already, but it has undergone a couple of changes. For example, it now has a collisions reactive property, which is of type int, and also this reactive property is no longer settable from the outside. So the only public interface we have shows the collisions as a read-only reactive property. This ensures that we can only change the value of this collisions property from inside the model. We can't change it from outside. The same goes for the already known marked for removal property. The model also has 2 very simple methods. The collide method, which increases the value of the collisions reactive property, and the mark for removal method, which sets the marked for removal Boolean property to true. Of course, we have a couple of tests for this cube model. These tests may seem a little bit trivial, but it is good practice to test everything. So the first test is collisions should be 0 after constructor, and basically it creates a new cube model and then verifies that the collisions value should be 0. Next, we have marked for removal should be false after constructor, and it's exactly the same. We create a new cube model, and the value of the marked for removal property should be false. Next, we invoke the collide function, and then the collisions value should be 1. And then we do a quick check of the mark for removal function, which basically creates a new cube model, verifies that the value of the marked for removal property is false, then mark it for removal, and then after that, the value should be true. So that's how it works. But how do we detect the collisions? If we go to the presenter layer, you can see here this part we already discussed, but then UniRX gives us the opportunity to just create observable collision triggers. And most of the Unity events have similar triggers that we can just create. After we do this, we are going to subscribe to this collision trigger and simply call the models collide function. Now take a look at this add to this and the end. This is very important that you haven't seen it so far. The add to this allows us to control the lifetime of this subscription. Basically, what it means is that the dispose method of the subscribe result is going to be called whenever this game object is destroyed. So that's what add to this does. But you can also just remove it if you say um, model.mark for remove subscribe, and then you do something. I'm just going to put here some an empty action, and then you say that this is going to be a disposable um, variable, and whenever you call d.dispose, the subscription is going to stop. The same happens if the observable indicates that the stream of observable items has finished, or if there's an exception. So now if we go back to the previous cube presenter test scene, you can see that here I have this cube, and I also have collisions and mark for removal, just like before. Well, the collisions is new. And when I start the scene, you can see that the collisions slowly counts up to 4. So let's see the rest of the logic, the rest of the models. On the model layer, the main thing is the main model, which I'm showing you right here. The main model is actually a singleton, so it has this instance accessor. Now, what we're doing in the main model is we have this number of cubes integer. We have an integer that says number of bounces before deletion, so this is set to 2 right now. And we have a collection of cubes right here. This is a reactive collection. This is something that we haven't met so far, but this is part of the UniRX library. You can think about this as an observable collection if you're coming from the MVVM work. Basically what happens is every time the collection changes, we're going to receive events. We are going to observe the count or the number of these cubes, and every time we add or remove a cube, this is going to fire. And whenever the count of the cubes is less than the required number of cubes, we are going to create a new cube. And then we create a new cube anyway so that we get this whole thing kicked off. Creating a cube is very easy. We're in the model layer, so we're only dealing with models now. And we are creating a new cube object, and we are going to add it to a composite disposable so that we can dispose of any subscriptions that we may have. And then we say that whenever the number of collisions reaches the number of bounces before deletions, then we are going to remove this cube. And we're going to add this subscription to this composite that we have here. And removing the cube is basically marking it for removal, removing it from the cube's collection, and cleaning up any subscriptions that we may have. Now, obviously, this also has a couple of tests. So we have tests when we verify that after the initializer, we have the right number of cubes. We have the second collision should destroy the cube. We have tests for second collision should create a new cube. Initially, all cubes should not be is removed, and mark all cubes to be removed command, because we have a command that marks all the cubes to be removed, should set is removed for all cubes. So we have all of these tests, but Note that these tests only run on the model level. So if I'm going to the unit tests here and I'm saying, and I'm running every single test, then I can run it standalone outside of Unity. Again, this is very important if you have any kind of continuous integration pipeline setup. But I can also change it to run in the Unity editor. This is when I'm running it in the Unity editor. And if I'm saying play now, very briefly you saw that they ran here in the editor. But the difference between running in the editor and running outside of the editor is that if you're running outside of the editor, you cannot access things like mono behaviors, the debug console, or anything very, very Unity specific. You can still access basic structures like vector 3s and vector 2s and whatnot. So in order to have your unit tests executable outside of Unity, you have to be very careful not to put any of those tests and not to use any of those classes and objects inside your test, which is great. It makes you fall into the pit of success because this way you have the proper separation between the model layer and the presentation layer. So very quickly, let's have a look at the main presenter. I'm going to close all of these and let's go back to the main scene. So the main scene has this thing that says cube holder. And this is the root object under which all of these cubes are going to be created. And we have the main presenter. If I quickly start this, you can see that the cubes are arriving and getting destroyed right here. Okay. And if I say that the number of bounces before deletion should be 4, it's going to have to bounce a little bit more. These cubes haven't even bounced enough, so we're running out of cubes right now. So how does the main presenter work? So below the main presenter, we have the main model, which is already tested, and we know that it can create the cubes and destroy the cubes after a couple of bounces. But how does the presenter work? How do these prefabs, these cube prefabs actually get created? Well, the way they get created is all here in the start. So I'm in the main presenter start, and what's happening here is after some initialization, we are creating a bound items container. Bound items container is part of the MVP toolkit, and what it does is that it hooks to a reactive collection, and whenever an item is added or removed to that reactive collection, it's going to create a certain prefab under a certain placeholder or a certain holder. So this is what this line does. We create a bound items container, and then whenever this addition actually happens and the object is created, we're going to subscribe to this add of the bound items container. And here, all we do is simply set up a random set of coordinates so that all the cubes don't appear at the same place. So this is a presenter level change that we can do to make the cubes appear all over the place. And we're going to turn off the automatic destruction of the cubes because we don't want them to be destroyed after a couple of bounces. We want them to wait in a blue state for a few seconds. And then we're going to observe the removal just like we observed the addition. Whenever an item gets removed, we are disabling its rigid body and collider, or just simply removing it. And then we are creating a 2-second time span. This is a very nice feature of UniRX. And after the 2 seconds time span has passed, we're going to destroy the object. And finally, the final step is we initialize the item container with the cubes collection of the main model. So this allows the items container to hook up to the main model's cubes collection, and then whenever an item is added to that, it's going to create a new prefab. Whenever an item is removed, it's going to run this, and then 2 seconds later, it's going to run this. And the cool thing about all of this is that the actual update function of the main presenter is empty. There is nothing there. And if this reminds you how with MVVM the code behind was almost empty, it's exactly the same principle. I hope you enjoyed this little trip into the world of enterprise Unity applications, UniRX and MVPToolkit. If you have any questions or just want to talk about any of these things, I'm open to it. You can see my contact information on the screen, and also you can see how you can download the MVP Toolkit for Unity. I'm very, very interested in your opinion. And now I'm open to questions.
Hey,
Hello, Andras. Can you hear me?
I can.
Great. I hear myself too. Let's see how we can fix. Well, whatever. Okay. Well, thank you for this great session. And
I'm glad you enjoyed it.
This is muted. Let me try muting some more because I'm getting crazy here. Hello? Yeah,
Yep.
that was it. Can you still hear me?
Yes, I can.
Yeah, now I can't hear you. Great. I'm not really sure what I did wrong. So, well, I'm glad you enjoyed. Thank you for this great talk, like I already said. Unfortunately, I can't hear you now.
Okay.
Because I think I have to unmute this tab. So, can you say something now?
I am saying something.
Great. Now I finally fixed this. What I wanted to know was like you talked a little bit about, a lot about UniRX. Could you tell me a little bit more about how the MVP layer of your toolkit translates to Unity?
Yeah. So the MVP means model and view, and in the middle there's the presenter. So the model layer is basically the data, what we have. And also in the model layer, you may want to put the business logic in there. It's actually model business logic, a presenter view, to be absolutely precise. And the model layer is just a bunch of reactive properties and objects that are tied together to reactive properties and collections or whatnot. The presenter, the logic layer is manipulating this model. The presenter layer is actually not talking to the logic, it's talking to the model and taking and reacting to all of the changes over there. And that's basically a set of mono behaviors. And then you have the view layer, which is the Unity object hierarchy. So every game object that you have with all of its properties. So the presenter is connecting the model and displaying it in a way that the Unity object hierarchy can follow. Also, the presenter, the events, the user events, or the collisions that you saw in my little demo, those are coming from the view layer and then go through the presenter to the model or the logic, wherever. So that's the layering.
I see. Can you tell me a little bit about the MVP toolkit? Can you tell me what your plans are? If you're already planning on releasing new versions, or if you have any contributors, stuff like that.
Yeah, the MVP toolkit is basically something that I'm trying to put together a collection of what I have learned about how Unity differs from this old way of working, which I found very, very effective throughout my career. And the MVP toolkit is just a collection it's a big sample and a collection of objects and classes that help you follow this whole process, and that help you follow this whole architecture, so that when you fall into the pit of success, as I mentioned, it's going to be really hard to do bad things if you follow this pattern. And that's the whole idea, to have an architecture for bigger enterprise projects that have to live on for 5-10 years, unlike a game, which usually only gets launched, and then maybe you have a few patches in the App Store or the Google Play Store, and then you go on to the next project. But the life of an enterprise project basically starts with version 1, and the life of a game ends with version 1. Also, with the game, you focus on gameplay, on graphics, on performance, on all kinds of stuff that are not so useful if you want to create a tool for, I don't know, a maintenance person to use every day and to help with their work. So that's the main difference, and my belief is that this difference has to be reflected in the architecture of the project as well.
You don't have to convince me. I'm just trying to get you to convince the people who are listening more that this is really important, because the usual Unity samples you get is like one big piece of spaghetti, and something happens somewhere, and something happens somewhere else. And I'm very glad you basically were the trailblazer in this, and I'm very happy to see that. I have a personal question. What's the V Bandy thing? Where does it come from?
So V comes from my first name, my last name, because in Hungary we have it the other way, which is Velvart, and the Bandy is basically a Hungarian nickname for András. It's that simple.
Okay. So does that mean that doesn't mean anything, actually? It's just a nickname.
No, but everybody asks me that.
Yeah, well, I mean, I use a nickname too, but it is.
Okay.
So did you get a lot of problems with if you move from one Unity to another? I mean, usually, like I said, moving from one version to Unity to another is like blindfolding yourself and stepping into a minefield. Does your approach help with preventing things like exploding in your face? Have you noticed that?
So usually it does, because every organized hierarchy or every organized architecture does help you pinpoint problems. But usually when you move from one Unity to another, then the problem's going to be in the presenter layer anyway. But since the presenter is not tightly coupled with the rest, and if you follow this whole, let's create unit tests for the models, logic, let's create test scenes for the presenters and the view, then you can very quickly pinpoint and very quickly go back to the place where the problem is, and try to find the solution.
Interesting. I'm looking forward to your next talk, when you're speaking on how you're going to create unit test for presenters, because that's something that's still a bit difficult to do, I think.
Yeah, I don't think I'm gonna do that in the near future. I didn't do it in XAML, and I'm not. I don't really think I'm gonna do it in Unity. But
well, I could try.
We can try.
Okay, I think
thank you for the moderation, my friend.
You're welcome.
I think our time is up.
Yes.
And well, thank you for everybody for watching. I hope this was interesting, and if you want to talk to me about this or anything else in the mixed reality space, then I'm open.